Hello everyone. As we are doing the Iupac nomenclature, so today we will discuss about some examples of the different functional groups. So let us start with this. So aldehyde group, you know well, is CHO group is present as an aldehyde group. So the first, as you have seen, the common name. There is a confusion कि Iupac norm और formaldehyde है. जैसे अगर हम इसको बोलते हैं formaldehyde. So formaldehyde is actually the common name. It is not the Iupac name. Iupac name में हमेशा क्या आएगा? Meth, eth, prop, but, like this. So we have to see this series of the alkane जो हम पढ़ते हैं वो include होता है. Methane means 1 carbon, ethane means 2 carbon, propane means 3 carbon, butane means 4 carbon, and so on. So that will be the Iupac nomenclature. So don't get confused कि what will be the Iupac nomenclature or formaldehyde या acetaldehyde क्या चीज है. तो formaldehyde is actually the HCHO group which is present along with this and which can be written as like this. So this is formaldehyde, which can also be used in preserving the species in the form of formalin. So the what will be the Iupac nomenclature for this compound? Is it methanol? Because as you have seen earlier that for the aldehyde the suffix will be written as -al. So it is methanol. In the second one you can see there is 2 carbon atom. So 2 carbon atom will become ethanol and it will be considered as acetaldehyde. कुछ ही कंपाउंड है जिनके आपको कॉमन नेम भी याद रखने पड़ेंगे. तो acetaldehyde. तो acetaldehyde में आपके 2 कार्बन एटम विद द aldehyde group and it will be considered as acetaldehyde or ethanol. In the next one you will see, first of all we have to write down the structure formula for this compound like CH3 whole twice. So CH3, C, CH3, H and CHO. This will be the structure formula for this compound. Now you can easily see what will be the nomenclature. It will be 2-methyl propanol because there is no any other functional group is present. So CHO will be get preference. So you will get 2-methyl propanol. Now in this compound you can see it is CHO group and there is a cyclohexane group. So that will become cyclohexanol. And at the third position the CH3 group is present. So it will be considered as 3-methyl cyclohexanol और cyclohexane कार्बेल्डिहाइड. CHO को हम एक चीज और से लिखते हैं that is कार्बेल्डिहाइड. Okay, so it is cyclohexanol or कार्बेल्डिहाइड. Now in the another one you will see that OCH3 group is present and you have seen in case of ethers in the lecture 2 or 3 we have discussed about the ethers that OCH3 group is methoxy group. So if you will see that 1, 2 and 3 at the second position OCH3 group is present. Presentation कैसे आएगा इसका? CH3 CH OCH3 like this. Up and down आप कैसे भी लिख सकते हैं and then CHO. ये chain में नहीं है. It is in the subsequent. So this will be 2-methoxy propanol. Okay. Now the next one is very simple. You can do it by yourself. Now here you can see there is a double bond present between the second and third carbon atom. So we have to write prop 2 in 1 al. Prop 2 in 1 al because at the second carbon atom there is a double bond present. So you can't write propane. It is prop 2 in 1 al. Now here in the next one you will see there is 2 CHO groups are present. So it is 1, 2, 3, 4, 5 and 6. At the first and second position, so it will become benzene. This is benzene 1,2-diol. It will be benzene 1,2-diol. That will indicate at the first and second position there is CHO group present. The next one you can do very well 1, 2 and 3. So it is 3-bromobenzaldehyde because the aromatic aldehyde will be benzaldehyde. So at the third position, now you can understood this position is the meta position that we have done in the previous lecture. Ortho, meta and para position. So it is meta-bromobenzaldehyde But in Iupac nomenclature, we are writing the position. So it is 3-bromobenzaldehyde. Now you will see regarding the ketones के अंदर क्या था? That is ONE will be the suffix. And if they are taken as a substituent, they will become oxo. So 1, 2, 3, 4 and 5. So it is pentane. क्योंकि डबल बॉन्ड नहीं है ना ट्रिपल बॉन्ड है, तो pentane at the second position on group, तो pentane 2 on. That will be the nomenclature for this particular compound. Pentane 3 on अगर होगा तो C double bond O will comes out to be at the third position. Now see, in this compound what will happen? First of all, write down the structure formula for this compound. CH3 whole twice means the CH3 will be present at the carbon atom like this. Then there will be C double bond O. You have to see the molecule. And accordingly, you have to write down the structural formula. CH3 whole twice में इस तरीके से structure formula हो गया. Now see, what will be the longest chain? 1, 2, 3, 4 and 5. Now, if you will see the numbering from this side or this side, the C double bond O will get the 3 position. Okay, it is a symmetrical compound. Similarly, if you will see the position of CH3 and the CH3 from this side, so it is 2 plus 4, 6. अगर आप यहाँ से numbering शुरू करते हैं यहाँ से, तो भी 2 plus 4, 6 आएगा. So this molecule is totally symmetrical molecule. So we will write the nomenclature like it will be 5 है carbon atom, तो pentane 3 on. Pentane 3 on will be the parent chain, and at the second and fourth position 2,4-dimethyl. So the nomenclature will become 2,4-dimethyl pentane 3 on. So in that manner you can do the nomenclature for the ketones. Now the next one you can see it will be C double bond O CH3. So it is cyclohexanol. Cyclohexanol. Okay? And at the second position there will be methyl group. So nomenclature will become 2-methyl cyclohexanol. Now in the next one you can see CH3 whole twice, that is CH3 whole twice like this carbon atom, double bond CH, C double bond O, CH3. ये compound है, ठीक है? So you can do the numbering. You have to see the double bond and the C double bond O group because it will have the high priority as compared to double bond. So यहाँ से numbering जब हम start करेंगे, then we will get the lowest number to C double bond O. अगर हम इधर से start करेंगे तो 1, 2, 3 and 4 position आएगा. So the right way to number the principal functional group should get the lowest number. So now what will be there? 1, 2, 3, 4. The third position पे double bond है. That means pent. We can't write pentane, so we will write pent. Then 3 in 2 on. ये हो गया parent chain. And at the fourth position there is methyl group, so it will become 4-methyl pent 3 in 2 on. Now from this nomenclature we can easily find out there is 5 carbon atom chain. At the third position there is double bond. At the second position there is C double bond O bond. On means there is a ketone, and at the fourth position there is methyl group present. Now you can see the more examples for the more practice, that is ethanol that we have discussed earlier. 4-bromo-3-methyl-heptanol means 7 carbon atom chain. 1, 2, 3, 4, 5, 6, 7 carbon atom chain. At the fourth position there is Br. At the third position there is CH3, and I'll indicate there is a CHO group present. In the next one, 3-methyl cyclopentanone. So first of all you have to see the pentanone, and at the third position there is methyl group attached. Cyclohexane carbaldehyde, I have told you earlier, whenever the CHO group is present, we may write the carbaldehyde, or it can also be known as cyclohexanol. Cyclohexanol भी लिख सकते हैं. Pent 2-enol, that means 5 carbon atom chain. At the second carbon atom there is double bond, and the ul means there is a CHO group present. So you can see 5 carbon atom chain, double bond and CHO group. 1-phenyl propane 1 on. This is the ketone group. 1-phenyl. Means at this position the phenyl group is present, and this is what? Propane 1 on, because this is a keto group. Now suppose you are having the functional group like, अगर आपके पास इस तरीके से प्रेजेंट है, 2 C डबल बॉन्ड O ग्रुप प्रेजेंट है, so you can easily see, again it is a symmetrical molecule, 1 2 3 4 and 5, so you may easily see it is pentane, because there is no double bond or the triple bond. Pentane 2,4 dione, so it will become pentane 2,4 dione. So these are the few examples related to the various functional groups. In the next lecture, we will discuss more examples regarding the different functional groups.